Network virtualization is the topic here at VMworld, and yesterday we went over a 101 with Brad Hadland, so you should know a little bit about the basics, but today we're here with Bruce Davie, and he's going to explain us a little bit more about the inner workings of NSX. Bruce, can you introduce yourself and what you do in the NSX team?
Sure. Hi, I'm Bruce Davie, and I'm a principal engineer in the networking and security business unit. I came to VMware through the Nicira acquisition, and I'm one of the lead architects for the product. For the last 9 months or so, I've been working pretty intensely with our hardware partners, trying to figure out the best way to bridge the physical world into the virtual networking world.
Perfect, well that seems the right knowledge that we need now. Could you explain a little bit more about how NSX actually works with the hardware partners? How do we do the integration? What cooperation is there?
Sure, I'd be delighted. Let me just draw a picture here. Sure. So let's just draw a few quick components. We've got some hypervisors with vSwitches in them. So we just drew a couple of hypervisors. We've got the NSX controller, and it communicates with the vSwitches. We have some VMs back here. And then we've got a third-party hardware switch from one of our many fine partners that can terminate VXLAN tunnels. It has some physical connectivity off to things like, say, racks of non-virtualized workloads, maybe database servers. And so the NSX controller has a connection to this device which uses a protocol called OVSDB. And of course the NSX controller also exposes this northbound API, and so it's through this northbound API that virtual networks are created, managed, monitored, and so on. So what we're going to do here is, let's say we want to create a virtual network that has a couple of VMs and some physical server. We like to just make a simple virtual network that looks like that. So we make a series of API calls into the NSX controller, and it would go and program the vSwitches to connect in the VMs, but it also needs to tell this physical switch how to build a virtual network that spans these physical ports into the virtual network over here. So what we do is we use this database protocol, and there's actually a little database server running over here inside the switch, and this is some software that we've developed and made available to our partners and that they've then customized for their products. So we can do things like, when a VM is brought up, we learn its MAC address, so we can tell through the database protocol and write into this table, say, there's a MAC address of a VM over here, and you could reach it at the IP address of this hypervisor. There's a whole lot of information goes into this database. At the same time, this physical switch can be doing traditional MAC learning on its physical ports, so it learns things like, oh, there's a physical MAC address out here, it writes that in the database, and that makes it available to the NSX controller. So there's a sharing of state between the NSX controller and the switch, and when all is said and done, this switch can now build VXLAN tunnels that connect to the appropriate hypervisors. It can program its forwarding tables to forward packets from, say, this physical server to this VM or that VM. At the same time, NSX programs the vSwitches here to forward packets back this way, and we end up with an overlay network that connects all these machines together as originally intended. And this was all done without any need to do any kind of flooding or any kind of multicast-based learning. Everything was just done in the control plane. We built the right tunnels, and you get this virtual network. So it really gives us the chance to do sort of consistent operations in the data center, whether we're dealing with virtual machines or physical machines, and it gives us this really nice operational model, everything done through a single API, where you can have a single pane of glass to manage all of your connectivity between machines, physical or virtual.
Exactly, so it actually makes life a lot easier. No need to manage the physical switches separately, it's all one control plane and everything just works with the same efficiency and flexibility as the NSX for the hypervisor only.
Our whole goal here with NSX has been to make the operational model of the data center very similar for networking to what it has been for quite a few years in the compute world. So now we've not only done that for interconnecting VMs, but now we can do it for interconnecting physical workloads as well.
Perfect. Well, Bruce, I know you're very famous in the world for some other work that you did. You're actually the lead of the architecture team implementing MPLS over at Cisco. There's a lot of talk about NSX being able to route as well, not just the switching. Could you talk a little bit more about the routing functionality and maybe MPLS and how we're integrating that into NSX?
Yeah, absolutely. So, I mean, we do have a quite sophisticated collection of routing features in NSX today. You know, we can do things like build logical networks more complicated integrated than this one that have different subnets and routing between those subnets. We can also run routing protocols from the virtual network out into the physical world so that you can advertise reachability into a virtual network, say out to the WAN, and as a way of attracting traffic into a data center. When we start looking at integration with MPLS, one of the things that we're developing right now is the ability to take a service provider's MPLS VPN service and plug that in to virtual networks in the data center. So for example, if I were a large telco, I could connect my cloud data center offering to my VPN WAN offering and now offer this sort of integrated service that would let me say to my customers, you've already got a VPN service from me, now you want to bring up some VMs in my cloud data center, it'll just look like it's another part of your own private network. So we're integrating those two together is something we're going to be doing, and we'll be using MPLS capabilities in NSX to interconnect the wide area services with the virtualized data center.
Perfect, so ultimate flexibility in the end for the customers and a very good way to onboard new customers or more services for the service providers. Seems like a very good solution.
Yeah.
Any final closing comments that you would like to make on how this is changing the world of customers? What's their feedback to you?
Yeah, I mean, in general it's been phenomenally good, seeing how much the customers really are sort of thirsty for this stuff, and I think we see this desire to simplify the operations of the data center. And for me, I've always thought of network management as the fundamental last unsolved problem in networking, and so it's really exciting to be sort of here where we're actually really addressing that and making, I think, some of the biggest changes to networking in the last 25 years.
Yeah, I fully agree, and it's about time because we're entering the cloud era. Networking was not ready for the cloud era by all those manual changes needed, but now it seems we truly are. Bruce, thank you very much for the information. If there's any more information that you would like, we will put a link under here that shows you, points you to the NSX website on VMware.com. Thank you very much, Bruce.
It's been a pleasure.